Let us look at equations that do not look like polynomial equations. And let's look at it through examples. So we have x plus 1 by x equal to 0. Now here x is not equal to 0 because of 1 by x. So combining these two terms, we get x square plus 1 divided by x equal to 0. Which means x square plus 1 equal to 0. X square is equal to minus 1. X is equal to plus or minus square root of minus 1. That is x equal to plus or minus I. So that was one example of equations that do not look like polynomial equations. Let's look at this. X plus 1 by x equal to 3. And here again x is not equal to 0. So again x square plus 1 divided by x equal to 3. X square plus 1 equal to 3x. X square minus 3x plus 1 equal to 0. And we can use the quadratic formula to arrive at the solution set. So x equal to 3 plus or minus square root of 5 by 2. Now here we have to make sure that none of the roots are equal to 0. Okay, x square plus 1 by x square equal to 5. Again, x is not equal to 0. So now we combine these, we get x to the power of 4 plus 1 by x square equal to 5. That is x to the power of 4 plus 1 equal to 5x square, and we end up with x to the power of 4 minus 5x square plus 1 equal to 0. A quadratic equation. Now how do we solve this? Let t is equal to x square. We solve it using substitution. So our equation becomes t square minus 5t plus 1 equal to 0. Again, using the quadratic formula, we arrive at t is equal to 5 plus or minus square root of 21 by 2. But this is not the final result. We need x equal to. So we do substitution back. So x square is equal to t. So t we substitute it with x square. So which means x is equal to plus or minus square root of 5 plus or minus square root of 21 by 2. X plus 1 divided by x minus 1 equal to 2. Now here x cannot be equal to 1. Otherwise, in the denominator we end up with 0. So x plus 1 equal to 2 times x minus 1. X plus 1 equal to 2x minus 2. Simplifying it, we get x equal to 3. And it is not equal to 1. Fifth one, 1 by x minus 1 plus 1 by x plus 1 is equal to 1. And here x is not equal to plus or minus 1. Because if it is plus 1, this denominator becomes 0. If it is minus 1, this denominator becomes 0. Again, combining x plus 1 plus x minus 1 divided by x square minus 1 is equal to 1. 2x is equal to x square minus 1. X square minus 2x minus 1 equal to 0. And again, we can use the quadratic formula. So x equal to 2 plus or minus square root of 8 divided by 2. Square root of 8 is 2 root 2. 2 is common to all the terms. So x is equal to 1 plus or minus square root of 2. Now, sixth one, x divided by 1 plus 1 by x equal to 2. And here, even if these restrictions are not given, we should be able to figure out what values of x are not valid. 1 by x, so x cannot be equal to 0. 1 plus 1 by x, So 1 by x cannot be minus 1. 1 by x will be equal to minus 1 when x equal to minus 1. So x cannot be equal to 0, x cannot be equal to minus 1. Simplifying it, x divided by x plus 1 divided by x equal to 2. That is x square divided by x plus 1 equal to 2. X square is equal to 2 times x plus 1. X square equal to 2x plus 2. X square minus 2x minus 2 equal to 0. So x equal to 2 plus or minus square root of 4 plus 8 by 2, which gives us x equal to 2 plus or minus square root of 12 by 2. So x equal to 2 plus or minus 2 root 3 by 2. That is x equal to 1 plus or minus square root of 3. So 1 plus or minus square root of 3, square root of 3 is 1.732. So when we add it, it is not equal to 0, it is not equal to minus 1. 1 minus 1.732, which is again not equal to minus 1, not equal to 0. So we have arrived at the solution set. Okay, seventh one. Square root of x plus 1 is equal to x minus 1, where x is greater than or equal to 1. Okay, how do we solve this? Squaring both the sides, we get x plus 1 is equal to x minus 1 square. X plus 1 equal to x square minus 2x plus 1. X square minus 3x is equal to 0. So x is equal to 3 plus or minus square root of 9 minus 0 by 2. We could have done the factorization also. X common out, we could have taken out. Anyhow, so x equal to 3 plus or minus 3 by 2, which gives us x equal to 0 and x equal to 3. Now, since x has to be greater than or equal to 1, the only solution is x equal to 3. Just to verify it, substitute x with 0. So square root of 0 plus 1 is equal to 0 minus 1, which implies square root of 1 equal to minus 1, which is 1 equal to minus 1. So that is a wrong statement. Now here extraneous means not applicable in the context. The degree of the polynomial obtained after transformation tells us how many roots the polynomial has, not necessarily how many solutions the original equation has. This is very important. It is important to identify the restrictions on the domain while understanding the problem statement, if they are not given. Here, of course, it was given at the problem statement stage itself. But if it is not given, we have to make sure that we identify the restrictions. Verification then allows us to identify extraneous solutions. Let us look at the eighth one. Square root of x plus 2 plus square root of x minus 1 equal to 3. Now restrictions are not given. So let's see whether it is really required or not. We have square root of x plus 2. The square root symbol, when we use, it means we are talking of real square roots, not complex. So, which means here x plus 2 has to be greater than or equal to 0. And x minus 1 has to be greater than or equal to 0. So, x is greater than or equal to minus 2 and x is greater than or equal to 1. Now combining these two, we can write it as x greater than or equal to 1 because of this and. Both conditions have to be satisfied. That happens only when x is greater than or equal to 1. So we have our restriction in place now. Now squaring both sides, we get square root of x plus 2 plus square root of x minus 1 the whole square is equal to 3 square, that is 9. Expanding the square, we get x plus 2 plus 2 times square root of x plus 2 times square root of x minus 1 plus x minus 1 equal to 9. Simplifying it, we get 2x plus 1 plus 2 root x plus 2 root x minus 1 equal to 9. 1 we take it to the other side, it becomes 8. 2 is common. So we divide both sides by 2. We get equal to 4. Now we can take this x to the other side. So 4 minus x, that is square root of x square plus x minus 2 is equal to 4 minus x. But again we end up with a restriction here. 4 minus x has to be greater than or equal to 0, which implies x is less than or equal to 4. So therefore, x has to be between 1 and 4. Taking it further, we square both sides. We get x square plus x minus 2 is equal to 4 minus x square. So x square plus x minus 2 equal to 16 minus 8x plus x square. X squares cancel out. So we have 9x equal to 18, and that is x equal to 2. And do you notice that x, that is 2, is between 1 and 4. So that was our first part of equations that do not look like polynomial equations. See, this doesn't look like a polynomial equation, but it transforms into a linear equation. Here, this equation transforms into a quadratic. Here again, it transforms into a quadratic. That's it for now. Bye.